Hello, everybody. Thanks for coming before lunch. Do appreciate it. My name's Gavin Velser. This is Colette Awad and Brian Shake. We work for Accenture Federal Services. We're going to give you an experience conversation, not a product conversation. So if you're looking for a deep dive into Ansible or Docker, feel free to leave. It's okay. We're going to tell you about our architecture experience with the products, what we've done with them, the challenges we ran into with them, and a lot of kind of hopefully things that'll be useful to you if you're applying them today or you have or what have you. Trying to give everybody kind of a little insight into the challenges we ran into. So the little backstory on it. So we were about 18 months ago working to rebuild our application. We had a two-platform application, part on the mainframe, part on the mid-range. And we were working to rebuild all of that application, take it off the mainframe, put it onto the mid-range platform. As part of that, we decided great opportunity to tackle the dev arc that has always been lacking and has always been kind of not fragile, but generally not evolved and not capable of being able to handle the needs of what we previously had, and of course what we're going to have in the future as we kind of continue to evolve the application. So we were out at up in Boston last year and heard all kinds of wonderful things. At that point in time, we'd already were underway with a lot of this, but we had heard a lot of wonderful things. We heard 100% automation, not 98, not 99, but 100% automation. We heard we needed to get rid of all of our pets and adopt some cattle. And we also heard that containers would solve all of our problems. They kind of have a little bit. They've definitely solved a lot of our control issues that we had some challenges with. But we took a lot of that and injected it into what we've done here, not only with some of the architecture principles that we put in place with the new application, but in addition to that, the the underlying development architecture that we put in place. So we just to take one more step back, sorry. So what we did this is for one of our, as I said, we were from Accenture Federal Services. This is for one of our federal clients. So we applied this or created this within the public sector realm. And I always like to look at it as somebody who primarily works in the public sector, is that if you can do it there, get through the security hurdles, get through some of the compliance challenges and all that, generally rolling this out anywhere else is kind of easy or a lot easier. So if you can get through it there, it's a lot easier to get through it elsewhere. We're probably not going to tell you anything you don't already know. Since you guys have been here for the past 2 days, you've probably already are experts on Docker, experts on containers, and experts on Ansible. So we're not going to go too deep into each of those products, but as I said, it's not a product conversation, but we'll tell you about how we applied them. One of the things that you'll hear about a lot theme-wise is that the complexity that we were trying to tackle is kind of what drove a lot of the design decisions that we made to make all of this happen. Is the complexity. That's kind of what we had to deal with. It wasn't a simple thing where we saw in Boston last year, just go click, 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 OpenShift layered in, done, 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 and look at that, you've got yourself a containerized environment, your application is deployed, and it's running. I wish it was that easy, but not even close. A few things to think about, and feel free to think about anything you like. You don't have to think about this presentation, but a few things to think about that kind of key pieces on this presentation. It's DevArch, not DevOps, although DevArch is a path to DevOps. They're not synonymous. A lot of folks like to make them synonymous, but building a good, solid DevArch foundation will enable the DevOps very much so, and generally that's the path that we're on. 100% automation, however you get it done, leads to consistency, and what you want out of the automation is consistency. You don't necessarily, the automation is fantastic and it's great, and however you achieve it, make it happen, is the consistency that you want. Being able to have consistent environments from your lower all the way up to your production is the most important thing there. And then the other thing is you don't need a lot of fancy tools. Fancy tools are great, but a lot of what we did here is generally a lot of scripting, a lot of blood, sweat, and tears went into it, and a lot of good design principles. You don't need to have every AWS service available to you or all these other services that are going to basically do all the work for you magically, and then just there you go, you've got your continuous integration and deployment architecture. So let me jump into it. That's my little preamble. I apologize if that was long. So bear with me through the initial slides, or what I consider the crayon slides a little bit. So what we had previously We had, as I said, we had two platforms. We had a mainframe platform, mid-range platform. They were generally coordinated via mostly heroics. So we had had our COBOL hardcore developers writing code, updating code via their TN3270 emulators, checking that into Endeavor, and then they were updating a separate tool that we developed to manage migrations. So they were basically checking in and over here, going over to this tool, identifying that they checked it in, and then that would go through a process, not an automated process, mind you, but a process to then migrate that code. On the mainframe side of it, although there are many tools out there, and I'm sure that if we pursued them, we would probably find a lot of automation out there. We didn't, but maybe we could. But challenges with branching, challenges with the number of paths we had on the mainframe, no automation, lots of confusion, and lots of heroics that generally enabled things to get into the right place where they needed to be and move through the environments. On the mid-range side, we were a little more mature. Nothing exciting. We had a Subversion with Hudson, eventually moving over to Jenkins, and Nexus as the artifact repository. So we had that in place, and it worked pretty well. We basically had builds on check-in. We had deployments via automated deployments of sorts, and it was a pretty good solution. But what it was predicated on was that we still built the environments by hand. So it was still somebody in there tinkering, managing an environment change in coordination with a config change, in coordination with a code change, in coordination with all the changes. And it generally led to just never-ending heroics on the DevArch side to make sure that everything stayed together. So the process we used to have, just to kind of belabor the point a little bit, just to understand probably a similar place that you folks are in, or we definitely have seen a lot of other clients in a similar place in other projects. So our developer will check in code, whether it be on the mainframe or the mid-range. They will update the tool to say the code checked in. They'll send an email. The tester gets the email. The tester says, oh, I'm testing this. Okay, well, let me migrate it. Okay, I'll migrate it in a couple hours. Okay, they send a migration email over to the project manager. PM approves it. That then goes over another email that says, all right, we're ready for migration into this environment. Our DevArch person would check the tool, migrate the code, update the tool, and that process is done, and then we do it over and over and over again. It just didn't scale. And the fact that we lived with that process for years was a bit of a frustration. It was one of those things where we definitely wanted to get away from it, but there was never an opportunity to get away from it until we found our opportunity to get away from it. All the coordination that occurred, whether it be a data model change that needed to happen, and many times the code migrates, doesn't work, doesn't deploy because we've got the data model change, or we forgot the configuration change. All of that was completely heroically coordinated, or I forgot about this, the developer updated some configuration data in the database, and then it rolled in. So it just didn't work. It didn't work for what we wanted to do. We were doing too many releases, too many changes. It just didn't work at all. So it was pretty clear and obvious to us that the complexity of what we had as we were about to embark on rebuilding our application, we needed to do as much as we could to get ourselves in a position where we could maintain it and not basically just be up all night trying to maintain it day in and day out, even though there's a little bit of that in the growing pains. What we had was we have 25 different applications. So it's not one application that has a cute little web server and has a cute little app server and a database in the back end that's nice and distributed. That we don't have. We have a lot of legacy applications. Legacy, I only put it as in the sense of heavy business rules, business functionality. 25 of them, 4 different public-facing websites. And that's what we had to tackle. We didn't tackle one of them. We didn't tackle 2 of them. We tackled all of them. We brought it all into the same realm. We basically said we're going to automate it all. Otherwise, we're not going to do any of it. We maintained still and previously 5 major releases a year, which generally were good overhauls of probably a good 50% of those applications with each one, plus service packs, plus any expedited emergency changes. We did all of that in 8 environments, so we basically, all of our environment-based stuff was based on the mainframe. So on the mainframe, we had eight static environments, again, built by hand. Those correlated to 8 environments on our mid-range platform, which, again, built by hand. And those environments provided us 2 different release paths to production. So that meant if we were trying to do 2 overlapping releases, we had an opportunity, but if something broke in production, we generally were SOL. So it became a huge hurdle of trying to manage code into this environment or into that environment in order to balance everything out. So we need to get away from it. So as I mentioned, we're overhauling our DevArch, but the application changes that we were doing. So what we were doing at the same time that we were building this DevArch foundation was we went and we were taking everything off the mainframe. So that included taking a pretty heavy CICS transactional layer on the mainframe and moving it into EAP. So we created a multi-tier EAP architecture that mimicked a lot of the workflow pieces that we had within CICS into EAP. It was a lot of code, but at the end of the day, it actually worked rather well from a transitioning standpoint. We moved all of our batch processing, all of our COBOL batch, all the heavy batch that runs in the mainframe over to the mid-range. We have had lots of experience with Spring Batch before, so it wasn't a huge lift to do Spring Batch. It was more the business pieces of it that had to be pushed over into Spring Batch. We moved all of our non-EAP websites. We'd already had EAP for 2 of our public-facing websites in place, and generally love it, and the configurability that comes with it. And we removed the other 2 websites that were previously running on WebSphere at another data center into our data center and replatformed them on EAP. One of the things, just take a minute, one of the things we found with EAP was it wasn't as easy as we'd hoped, but it definitely wasn't hard either. We had very minimal hooks into IBM proprietary stuff, so it made it a lot easier because of that. There were a few hooks into data center provided services that we had to rip out as well and redo. But for the most part, we moved our data sources, we moved across any other JNI configuration, everything that needed to be done pretty easily. In addition to that, as part of this, even though, as I mentioned, we have all of these different applications, what we tried to do is take a moment in time and establish a distinct service tier. So we established a service tier within the enterprise in order to at least a little bit modularize some things. And then, of course, we moved from DB2 to Oracle, which was probably the most dangerous and complicated thing that we did. Not only redoing the entire data model and doing a full data migration, but generally we had to get rid of the old DBAs and find some new DBAs, the new Oracle, and go through all that. So I give you that backstory as just more, that was the architectural application execution architecture challenge we had in front of us there. And while we were doing all that and building this application, brand new code, we were working on getting the DevArch sorted out as well. So thus automation came. So some of the goals we had with automation, accommodating more environments, more release paths, infinitely more release paths really, and accommodating more releases. That was a big thing that we had always struggled with, and we basically spent hours and hours and hours trying to sort out plans for how we were going to get around things like that. And now we have a situation where we don't have to get around things. We just spin up another environment, and keep moving. 100% automation for all the environment creation, less hands-on. Everything has to be automated. When we build a new environment, it runs and it builds, and that's it. And if we need to tear it down, we have complete confidence in the fact that we can rebuild that tomorrow exactly the same way without any concerns. Coordination of all the changes in the environment. So previously you have the automation of that code deploying. Now it's the coordination of all the config stuff, all the data model changes. Generally, any change that goes in that environment is coordinated across the environment. That's one that we're still working on, but at the same time we have a path in place to get there, so that any change that goes in is fully coordinated. Some consolidation of some authentication pieces, the use of containers. So in performance test and production, and performance test simply to mirror production, it's all virtual. But we wanted to make use of containers for the pre-prod so as that we have control. Provisioning hardware is hard, trying to get VM spun up is hard, changing a VM is hard. Containers are easy, so we made use of containers. So our container architecture modeled very much so what we had for our performance architecture and production architecture. And then, of course, eliminating the human factor. A couple of tenets that we took in there was, if it can't be automated, get rid of it and redesign it. We've yet to find anything that can't be done like that. Environment complexity should never be a factor, so don't let it be a factor, and that kind of leans back to the first point. 100% automation, not 99. 99 is great, 100% is better. Reducing any vendor lock-in. We love open source. We love to not pay for software. We love free software. We have no issue with supporting it ourselves, so we dive on free software. We love open source stuff. So continuing that approach and trying not to bake ourselves into something that's just going to be a pain in the butt down the road. And then, of course, it has to be manageable. We're going to rebuild all this stuff, spend about a year rebuilding all of it, so we had to make sure that we automated it for a manageability standpoint. So what we needed to do, get all that done, was we needed a configuration repository. As I mentioned before, complexity. We needed somewhere to store all the configuration values. It wasn't a properties file-based solution. Properties file-based solution would never work for us. We have too much stuff going on, too many integrations. It would never happen. We needed that engine. We needed the engine. We needed an automation tool in order to get it done. We needed a platform with Docker, which allowed us the flexibility to build stuff quickly and change stuff quickly as well. And then we needed a lot of smart, new people. So no one that was there, jaded, grumpy about what we had done before. It's putting in a little bit of a cultural shift by people that don't know any better, a little bit of what it was, and understanding that what it needs to be, and putting them on that path. And then time. Never-ending time. As I mentioned before, it's not a 1 month or 2 month exercise. And of course, unless you're doing something very straightforward, it's a big time commitment. So team size, we expanded it, right? So our old team had a pretty standard CM team, handled migrations, builds, push this, move it around, whatever it needed to be. To address the needs of what we needed to grow into, we ended up with identifying a resource to handle Ansible. So basically, we created an Ansible SME. We created an automation team, basically call it our script kiddies, but a little more educated than that. They basically scripted the crap out of everything. An infrastructure team to basically be able to manage the VM aspect of it along with the container aspect of it, and then the CMDB piece, which is a key factor in our ability to actually be able to flexibly grow all the applications into what they needed to be. And this slide's only here because it just shows us all the stuff we use. It doesn't really provide any value other than that. But I do like the Springfield power plant. Because we took a lot of products and put them into a very complex scenario versus what we were doing before, which was about as basic as it comes and rudimentary as it comes. Definitely not the risk that comes with a nuclear plant, but it is a lot of complexity that we've instilled within it. And now I'm going to turn it over to Brian, who's going to take you guys into a little more depth. So Brian and Colette will dive into the details. I was just kind of setting the stage a little bit, getting the boring stuff out of the way. These guys will take you into the details of what we've built.
Hi, I'm Brian Shake. So we're going to go a little bit into, so this is more or less what our current state is. We use some of the same technologies we had used in the past: Jenkins, Nexus, source control, for Subversion. The difference is that we're using something that's fully automated end to end, but it's manually initiated. So we've got a CMDB, and I'll talk a little bit more about that in the next couple slides. We have processes to create environments where we can say we want a new environment of a specific type of environment. We can fully automated create that environment, provision it, and then allow developers to push code. So we're using Jenkins as kind of a means for UI for all the developers and anyone wanting to make changes. The Ansible using Tower for role-based access control, and then Datical for database changes. The Docker really is like a kind of a game-changing technology that allows us to be able to spin up these environments. We can simulate something like performance test or production on a single VM without needing to provision extra hardware. You can almost all of our like DevArch or other tools are all running in containers using like best practices. We'll probably look into moving those into OpenShift or something similar with Kubernetes. It's a perfect model with microservices. Let's see. So the kind of the building block, number one on here is the architecture. So we needed to build, it's something we'd never done before. The architecture, all the products, EAP, et cetera, were all kind of hand-built. So when they're implemented in test, they're built into test, and then the same in production. So you'd have human error issues. Managing configurations was very complex. You had to have someone that was really like a hero at building this and maintaining it, someone who really knew what they were doing. So it wasn't repeatable. So that was the first area we focused on. We stored everything in Nexus. We were able to consistently build out the web tier, the app tier, service tier, batch tier, reporting, the database schema, et cetera. So the next step, we kind of realized that the code changes, like there's going to be changing a lot. So we have a lot of expedited, a lot of emergency releases. We need to be able to track that, know when it's going in, and track all the different applications and versions going into each environment. So part of our CMDB is architecture. So it's what kind of the technical team is doing. The other part is what the developers are doing. So the code, managing that, managing the database changes along with that. And then we've split it up further so that we'll have a area where we store the application configuration, which could be changing daily potentially. And finally, the business logic for the batch schedule. So they're all different pieces that we kind of baked in over time. We could not have really done this all at once. We had to test it as we were going through. So we tried to use a process where we push these changes in on a regular basis and enhance and improve and see how it works, see how it responds, how people like it, feedback, and then go through the same process. So we were trying to use more of an agile process for developing our own tool set. So this is kind of the key to what allowed us to be able to support the number of environments that we've had. I think we probably currently have 30 or so full environments, varying scale. Not all of them are multiple web nodes, multiple app nodes, but they all have at least one. So there's version control, and we kind of broke it up by, we've got a lot of values that are going to be the same everywhere. Like for a certain release, they'll be the same values. So we've got memory settings or configurations for the application, and a lot of these applications are legacy. They've been enhanced and changed over time, many years. So they've got a certain level of complexity to them. So there's a good number of values that will be changing as we go through different time periods, maybe pointing to a CDN, different CDNs potentially for different environments. So there's a concept of regions where we have prod, pre-prod. They may point to different infrastructure components, mail servers, NFS. The types, so we have, you can be broken up in any way really, but we've broken it up by the different types of testing environments we have. So like user acceptance test may be different, have a different authentication provider. The environments are created, so the last two are ones that the system sets for you. So you create a new environment of a certain type, and you put it on a specific Docker host or set of hosts, and then it can take care of assigning ports for you, doing all of the work that would be done manually or could be done through Kubernetes in a different way. But essentially, the top three are the ones that are all being version controlled. So you have an inheritance with different versions. It's kind of a capability that we hadn't seen available in the market. So it's something that we ended up building ourselves, some way to store the configuration, version control the configuration, be able to support constant releases, constant expedited releases, be able to track all of that, and have an authoritative source for all of that information, along with, given that it is a federal client audit going back. So let's see. This is kind of pretty high level overview of some of the applications. We've got the API, of course. It's kind of the key with the Postgres database behind it. That is the means of updating, providing the JSON output for Ansible. So it provides all the information needed to configure an environment, to deploy code, to know all of the ports, IPs, usernames, passwords, etc. The kind of a couple of applications that work alongside it. There's one that's designed to provide status. So one of the issues we've always run into in the past is what code is where, what version of something is where, like what is the IP address of this, or the how do I access this particular resource? In the past, we've had sites that were manually updated. Maybe someone missed updating a site, and so it's always like a kind of a area where people are always asking and then need some way to verify that it's actually correct. So we built a site that provides all that information, and it's actually authoritative because it's pulling from the same database that was used to configure the environments. And then alongside that, a separate user access site. So all of the access in the Oracle databases, or the Linux environments, or the LDAP, all driven from this same database. So someone can go in and easily reset their password, storing hashes in the application, and then push that out to the LDAP Linux containers, or Oracle databases, or probably any other system could be easily adapted to the same. So the Tower is more or less a nice way to provide a role-based access control for that, but Ansible is doing all the work. The JSON output from the CMDB is everything that you see here pretty much should be able to be pulled from that. So we have the same type of integration with test tools. Test tools can go and grab a list of environments. They could target a specific environment and then grab details like the way to connect into the website that they're testing, or this website, this other website, using credentials, anything that we could use to be able to fully automate the process of launching and running tests in a repeatable manner. I think next up is a little more detail on some of the technologies in fact.
Hello? Okay. One of the first things we had to do was select an automation configuration management tool. We needed something that would give us the flexibility to work across both VMs and containers and treat them in the same manner without having to manage separate sets of scripts for both containers and for VMs. We also wanted something that didn't require us to staff developers in order to be able to write and manage scripts. We wanted something that was easy to get started with and to work with. And so with that in mind, we ended up looking at the four major players in the market space, which were Chef, Puppet, Ansible, and Salt. We ended up going with Ansible, and some of the things that we liked about it is that we felt that it was more targeted towards architects and sysadmins instead of developers, and so that kind of went into one of our initial requirements. It uses YAML, so writing playbooks is very straightforward. It's easy to use, easy to learn. You could have somebody who's never even seen YAML before go look at a playbook and pretty much understand what this playbook would do if they were to just run it. In addition, if Ansible, if there was something that out the box didn't work for you or didn't have all the capabilities that you had, you could go and extend it and create your own modules using Python. Another key thing for us was the agentless architecture. We did like the fact that you didn't have to have agents set up on your containers and on your VMs in order to get working with it, just simply using SSH key-based authentication. And so that kind of helped us be able to treat containers and VMs in the same way. Other things that we did like as well was being able to register reuse variables. In addition, the whole managing the same way. And we felt that the documentation was actually pretty good. So as is the case with going with any new contender in the market space, there were some risks associated with that. I mean, Ansible was basically the newcomer in the market. It had a growing community. You had Puppet and Chef there that had been well established, that had been very mature, had been around for a long time. But given the pros for us, we felt that it was worth the risk. And the past acquisition from Red Hat this past year, I think, ensured that we'll end up having a number of years, at least, of continued support and continued development and a growing community. And then for us, so why containers? Specifically, why Docker? For us, it pretty much comes down to control, or rather just a lack of control that we had on our infrastructure. We pretty much, the current infrastructure, the old infrastructure that we had, as Scott mentioned, any change that you really need to make, you'd have to put in a request to our data center. It's about a 2-week lead time. Even then, it gets done by somebody manually. It comes back to us. It's not always exactly the way we wanted it. We'd have to go have some back and forth, and it was not a very efficient and flexible way for us to operate. So we needed something that gave us more flexibility and more control on our infrastructure. So it also, we weren't ready to throw Docker into production at the time. I mean, it was still a new concept for us. We needed to prove out the performance, all that stuff, but that didn't mean that we couldn't use it for everything that was earlier than performance test. I mean, we even use it for some performance test, and then later performance test, we have traditional VM infrastructure. So, but I think we were able to use Ansible to treat them both as containers and VMs in the same way by mapping our granularity of our containers the same way as our production VMs. So where we would have an app server VM, you'd also have an app server container, same for the web servers and all that, batch servers and so on. So, and the whole thing that Scott talked about with treating like cattle, not like pets, I mean, the way we have now, the environments are pretty much reusable, not reusable, disposable. You can pretty much tear it down, rebuild at any time if you think that something's gotten corrupted maybe, or just you want to test your automation, just blow it away and start again from scratch. And the main thing for us was the whole control issue. We didn't have control and we needed control. So other useful things for us as well with Docker was the application runtime isolation. We're able to stack a lot of containers, different environments on the same VM now, and not have to worry about any types of conflicts or shared runtimes causing issues. In addition, the infrastructure agnostic was really good for us because we didn't care what our underlying infrastructure was as long as you had Docker running. It didn't matter if you had Red Hat 6, 7, whatever. As long as you had Docker, you used the same base images, you pretty much ensured the same consistency across the board. And back to flexibility and control. That was the key thing for us. So bumps and triumphs. I mean, this was extremely painful. I mean, we had so many problems along the way, but at the end of the day, it was all worth it. I mean, anything that you'd expect to go wrong went wrong for us. I mean, we had just about every issue. I mean, there were environment instabilities. You had environments like that. We stacked so many on a VM, and then we had conflicts between the Docker versions and the kernel version. And I mean, it would be 5 o'clock, 6 o'clock on a Friday evening, and then 20, 30 environments would start one by one crashing, and the whole VM would crash. And given that we were still in our infancy stages of our automation and our scripts, it would take us the whole night, and we'd just stay up a whole night just to bring all the environments back up. What Brian and Scott both touched on, the config management as well, keeping code and config in sync. I mean, that was an issue for us as we kept growing as well and having more and more environments. Yes?
I have a question. I see from last couple of days or even the enterprises, mostly they are talking about containers. So what is your roadmap on Red Hat virtualization?
What's that? What is?
What is your roadmap on Red Hat virtualization?
What's our build platform?
We don't presently have a roadmap on Red Hat virtualization.
Yeah.
VM or the hypervisor that you offer?
We make use of VMware for the hypervisor.
You may use VMware.
Make use of VMware. What's that?
You
We use VMware for the hypervisor. That's correct.
Okay. So another issue we had, deployments. We thought it was a good idea to open up our deployment infrastructure to our developers, and we gave them control. You know, one of the sessions I remember last year we saw at Red Hat Summit was like, all right, give developers control, let them deploy everywhere, even to production. So we didn't do production, but we did, you know, a lot of our earlier environments. And that was, maybe we weren't ready for that just yet, because what happened was, or maybe they weren't ready for it, but it was every build that they would have just completely untested. The build would come up, they would just go kick off deployments to all 20, 30 environments that we had, and then they'd realize something else went wrong. They would go and try to do the same thing again and again, and then you'd have that across 30, 40 developers, and it wouldn't be unheard of that you'd have like this deployment jobs like just hours backlogged, just waiting to go in, and that was one of the biggest complaints that we have. And I mean, to us, it didn't make sense that somebody would actually go and do that, but that ended up being our experience. In addition, of course, our deploy scripts were still pretty early on, so we were, you know, still learning about how to optimize and make our Ansible scripts more efficient and able to be reliable. And of course, the limited infrastructure. I mean, as soon as everyone found out that we can start giving them a capability that they didn't have in the past, creating more and more environments, everything just became critical for everyone. So it's like they needed 5 of these environments, 10 of these environments, and we got to our saturation point and our max capacity pretty quickly, and we had to start kind of prioritizing who was more important or whose needs were more important. And then, of course, lots of bottlenecks. I mean, we were still early on, so our error handling wasn't completely in place. We had jobs that would hang. We'd have jobs that were slow. So it wasn't a smooth process, but at the end of the day, it was definitely worth it.
Were you guys maintaining the basic middleware image catalogs, and they would just use your images to deploy their code?
Well, we exposed through Jenkins to Tower, and we would have the Tower jobs there able to kick off the code deploys. So they would select whatever build that they wanted through Jenkins, and then that would stage it to a Nexus repository that we had, and then that would be used to trigger off to the environments or the environments that they selected.
So the environments were a little bit longer lived. We did have base images, and we created an environment. So we created an environment for this particular release testing for code component and for the functional team testing, for the test team testing, et cetera. And then code was pushed into that on demand. So it wasn't stood up for the code deploy. It was already stood up, and then code was pushed into it whenever the code was ready to be moved there.
So right now our environments pretty much last typically for the purpose of the releases. So once we get the release going, we'll spin up whatever environments are needed, and then when the release is done, recycle them.
So did you maintain the automation that would actually build their code, or did they provide you, basically here's my ear or
It's all Maven-based builds in Jenkins. So.
Correct. Generally, they provided the code, as in they checked it in this version, and after that, it was pretty much hands-off from their perspective. All of that was wrapped around that to basically provide that service to them.
how did you deal with resolving, basically, at that point you owned the build back then, right? So you were basically, did they give you a set of rules for that, or how did you negotiate those things?
For the build itself, it was all Maven-based build process. So if the developers needed a different dependency, they'd specify it in the POM. And we've been doing something like that actually for years. So it's the whole build process more or less is pretty similar to what we had been doing. The difference is that we're using Nexus to stage code to be prepared for deployment, and then using Ansible to pull the code from Nexus. So it's that's more the change from the developer's perspective, that they're using the same build process they were previously using.
So like all your dependencies and things you storage, Nexus, is that like
Yeah.
Artifactory?
Yeah, exactly. Yep. Yep.
How do you handle approval for resource management? If everybody, if all your developers build up an environment on their own, how do you keep your hardware and your database infrastructure from getting overwhelmed?
So they don't build out environments.
We haven't
on
gotten
their
there yet. We haven't gotten to the point of self-service where they can spin up their environment
Yes.
yet.
That's in our roadmap, but we have.
Single like approval chain to say, okay, once this is approved, you hit the button and everything just goes.
Well, for the earlier environments, we pretty much, at that point, we gave control for them to go and deploy the builds that they wanted that were associated with whatever tickets that they were working with, the Jira tickets. For the later environments, that had to go through a more formal release management process where they would specify that this build here and get all the approvals done and then be able to deploy to the environments.
But,
So,
but,
Building the environment itself.
but you're correct. The event of building an environment is still a process. So generally, it's we need a new environment. We'll have it up for you tomorrow, type of thing. It hasn't gotten to the point of I need a new environment, work it off of this existing baseline spec, which we're working to do, baseline data loads, baseline configuration loads, and all that, and build it up for me. It's not that to the point where it's click and there's my environment and I can go do what I want and then I tear it down. Because to your point, we run into exactly that issue of the infrastructure limitations of everyone's going to build 10 environments because they have very complicated things to do.
Yeah, and that'll be things to think through, like when we're working through a means of providing the self-service using, like, I don't know, the release automation tool or something similar, loading in test data. We already have the configuration and reference data loaded into the database, but the test data is kind of the next step that's key.
I mean, right now, as part of our environment build process, I mean, it's a process, but it's not. I mean, a lot of the automation is in place that would lend itself to something like that. We have processes that go and create all of our database schemas. We have the user management on top of that as well that runs and syncs up everything. And then basically creating all the containers, building out all the components in those containers, deploying the code to them. All of that is a process, but it's all pretty much controlled through Ansible from the initial stage would be just simply going to the CMDB, defining a few pieces of your environment, like what the environment type is, and how many nodes of this and this and this you want, and then from there you would go and kick off your scripts to build out the environment. So, but that's still currently owned by us and not by everywhere else. So the whole resource limits and everything like that, it's still
We still manage it, exactly.
We'll get to that part. Yes.
So you build something and you give developers kind of carrots, so they're starting to use it, they want to use it.
Exactly.
What sticks are you going to put in place that mean that they free up their resources and don't just spin up 10 environments and then set them down?
We think we'll still have to work through that process, but I mean, maybe giving them a quota or some kind of a limit to what they can do, or maybe, I think we still have those are still things that we have to work through.
We don't want to limit them too much that they can't do their work. So it's a balance.
I mean, one of the things that we are considering in the future is also moving to potentially some cloud-based provider. So if we do that, then we could potentially spawn up more than we have limited currently with our Docker infrastructure or our VM infrastructure. So I think that's just something that we're still addressing, and we'll get to that pretty soon, I think.
So a lot of the stuff that we want to try to address is right now code is thrown over the fence a little bit. They can migrate it themselves, but codes are thrown over the fence a bit, such that they're testing in test environments as opposed to testing themselves. It's the never-ending problem I don't know how to solve, but trying to layer in potentially OpenShift so we can create smaller, more lightweight, basically making use of containers, but generally everything's on a smaller scale, so infrastructure-wise it's not as demanding. Pushing them into a place where they can have that self-service model, where they can have their own environment, do their testing in that environment with the proper configuration, the proper data loads and all that, as opposed to let me go break this environment by pushing my crap code over there and see how it works. And that's one of the challenges we have today, where it's a little bit of a free-for-all, so trying to control that.
Well, can we run through the last couple of slides and then we can open up for questions just to make sure that we get through them?
Yeah, I'd say hit on some of the key stuff here.
There's only a couple of slides left, so I just want to tackle the rest of it. So I guess the question now is, would we do it again if we had to start over? Yes, of course we would. There's obviously some things that we potentially, looking back, we would have done a little differently, but if somebody else wants to go and tackle this type of problem and start going about this route, I mean, things that they should keep in mind. I mean, as Scott touched on, you want a very engaged team. You don't want, it doesn't matter if they're juniors. You want people that are actually motivated, that are into that are into it. You don't want people that are kind of checked out, because it's not going to be like a 9-to-5 kind of job. You have to be basically ready to work work hard all the time and just get it all going. The biggest thing, common sense, design, plan everything, design it, then eventually consider building it. Put security into that design too. Don't try to factor it in later, because it becomes more difficult and more complex at that point. I don't know why we went with Red Hat 6, but that's what we had to use, and that's not something that that's not a pain point that you want to have to encounter working with Docker when you have much more modern OSs that are able to run it natively. OpenShift, when we started this whole process about a year ago, or a little over a year ago, OpenShift was still on V2, so it hadn't incorporated Docker in yet. So it wasn't something that we were able to really seriously consider. However, now that it does have Docker, it does have Kubernetes with it as well, and it will pretty much is something that we're looking at, and we're currently about to proof it out and see how we can incorporate that, because I think that's going to be a big step to us being able to productionize Docker, just being able to take advantage of some of the features that Kubernetes has, the whole scaling, the replication of everything. Don't re-platform your system, obviously, but at the same time. And then get everybody comfortable. I mean, there's going to be a lot of bumps along the way, but it'll be worth it for everyone. Some of our roadmap items, I mean, we have a lot of things that are still planned to do. I mean, we want to tie in a release automation process, just something to tie up, to kind of connect all the various environments so they're not just more of a standalone thing right now. So being able to treat the codes and the config throughout the release process from beginning to end, from the code check-in. Integrating Jira, of course. What else? CMDB, I mean, that's been awesome for us currently, and just further developing the CMDB, further developing the APIs for it, and getting that to be more feature-rich as well. Removing SSH access, I think that's something that we're definitely considering. I mean, if you expose everything, logging, all that stuff, there's really should be no purpose to people having to SSH into your containers, into anything, and that will help once we move as well to an OpenShift model, if we go that route. Productionizing Docker, that's definitely, I think we're getting much closer to that approach. EAP, I mean, next couple are just upgrades, EAP 7 and standalone mode. Right now we're at 6 and domain mode, but I think for it to work with more of an OpenShift type model, standalone is the common sense approach, so we were planning to jump into that. And then Ansible, I mean, they just released their upgrades recently, their new version, so it's not 100% backwards compatible, so we're just going to have to go and evaluate all of our scripts, refactor some of them, get them working, and maybe take advantage of some of the new features. And then lastly, the self-service model, I think, or one of the last, the self-service model, on-demand model, I think it would be cool if we can get to that state where people can go and select what they want and what applications they want in a particular environment and go down that route. And there are issues that we still have to work out, like the whole resource limitation. How do you make sure that they only get what they actually need? I mean, that's still stuff that we need to work out. And then the OpenShift scaling and replication, I think, are key things for us for this year. And we're open to new ideas at the conference, too. So if we come across anything cool, we'll throw it in our roadmap that's worthwhile. So there's our contact information. Questions? I can't. From the security perspective.
Sorry, what?
Well, the key learning from the Docker from a security standpoint.
So the Docker it provides a good level of separation, like namespaces, so that you can. It's really good for simulating like an environment, like a VM. From a security perspective, you're still running on the same kernel, so there's some additional. You're not getting the same level of separation as you would from a VM or a physical hardware device separate. But there's a lot of advancements there. There's like technologies that are being developed. SE Linux is a good way. With more modern OS, there's also additional protections that have been built in. So another reason to probably avoid Red Hat 6, in addition just to the headache you'd have with it. So it's an area that I think it's evolving. The space hasn't really necessarily caught up 100%, but. It's more the we need to kind of build confidence in it as a platform. There's some level of with a VM, we are comfortable managing it. The Docker container, it could be there, it could go away. It's a little harder from an audit perspective, but I think it's there, it's ready to move to that. It's just like ideally moving in Kubernetes, providing like an orchestration layer on top to ensure like high availability and containers are up when they need to be in case a VM crashes or something similar.
And just to be clear, we put the rebuild application live about 3 months ago. And the last thing we wanted to do was layer in containers at that. Not to say that would have been a terrible idea, but when rebuilding the entire application, to then layer that in, and then layer that in, generally try to stick with a little bit of comfort. But on the plan, the idea is that with the flexibility we get in the pre-production environments, there's no reason we wouldn't want that same flexibility in production. So I'd say we started conceptualizing a lot of this early 2015, right? So it's been a while, right? But we also were doing it while we were rebuilding all of this. So I'd say, one of the key learnings was, taking that point and making it an actual project of a 3 to 4 month project to actually layer in the automation, not while the application is constantly changing. Because we run into a lot of issues of, you're changing the automation, did that break the application, or did the application break the application? And when you're rebuilding the application, the amount of complexity we have in an application is painful, to the point where the business logic and the business rules that are in place are just painful. So any little tweak here and there, it must be the environment issue. And it's like, well, our scripts are generally rock solid. The environment builds, the environment's the same as that one, and that one. So that's definitely a key thing, is doing it like that. But we ended up, probably started 18 months ago, early 2015, taking it around, probably developing a good chunk of it this time last year, and then refining, and then ending up in production with the end state. I mean, a lot of this was done well ahead of production, obviously, but ending up in production with the end state in March.
Yeah, I mean, and there's definitely a lot of time, like, you want to evaluate all the tools that you reasonably want to look at in the market and make a choice based upon your own environment and your needs. So that took a good portion of the time, along with designing, creating, a lot of the upfront work to actually figure out how everything's going to integrate.
Yeah, that's the key. I mean, it's figuring out the approach you want to take. So if we say layered in OpenShift tomorrow, the approach for OpenShift is completely different than the approach we took, because everything routes through Ansible, as opposed to a different model where you're, say, building a container and then just deploying that container all over the place, versus building a container each time, you kind of uniquely automated in a very similar fashion, but arguably uniquely. So it's figuring out the approach that works best. And for us so far, this is good. When we say push in OpenShift, maybe that'll change the approach a little bit. When we push in something else, maybe that'll change the approach a little bit. We have to back up a little bit and then go right. Not really sure.
It'll definitely change that. It'll definitely change
the
configuration. It'll definitely change the configuration approach. So we just have to figure out the best configuration model, like you were saying. I mean, whether it's like a pull.
There's not a one size fits all, unfortunately. We looked for it, couldn't find it. So it was figure out the best thing that worked for us, and generally was able to handle all the complexity that we do have.
Yeah. Yes.
Do you have the application team to edit your standalone XML files for all the different levels? How do you let that manage things?
No, the configs, I mean, we manage the configs, so if they need to make any changes, they submit it to us, and we control all of that. So that's part of our deploying, configuring process through our automation scripts. Like, we need to vet out everything, make sure it's all smooth, rather than opening up access to where...
One of the great pain points that we had was that they'd make a configuration change over here, no one would know about it, it would migrate up to the next environment, and it didn't work, and we spent half a day trying to figure out what the heck is wrong. Why is that build working over there and not over there? And it's like, oh yeah, by the way, because they had update access on the database. Oh yeah, I updated that value. Sorry about that. And it's just, you just lost half a day. So yeah, no, we tried to, because of the Wild West show that we endured, we tried to pull in as much as possible. The idea is as much control and much consistency as possible into what we do. And farming it out has basically been unsuccessful. So trying to pull it in under one roof has been a lot more successful.
We do have a web UI on the roadmap to leverage the API so that someone could go in and with an account and be able to modify configuration values, potentially with some kind of like workflow or something, but to provide some of that ability to use the process to make changes, and that could flow through the normal process all the way through to production.
And then it gets versioned properly and pushed through, exactly right. The idea is that automation, that release automation piece of it will allow it to govern its way to production as opposed to just be over there and then in production it fails.
Yes.
Are you guys shipping like coupled code, like when the developers are developing their code, like, say this back end and this front end have to go at the same time, and going into environments, and then when you finally get to your production, are you deploying both at the same time, or are you guys decoupled?
I think it depends on what the issue that it's being released is. Sometimes we have simple deployments where it's just going to be like a small part of like the application. It might be the service layer, the application layer. Sometimes it'll just be some like Apache changes. So it doesn't have to be like a full deployment into production.
But presently, there's so many pieces to it that we are deploying it piece by piece. One of the things we did do is we went live in March. We basically on a set infrastructure footprint. A month later, we expanded that footprint a bit just because just the way it worked out. And we completely rebuilt everything at that moment in time. So it was one of those things where we went live, hooray, after many, many months of struggling, and then rebuilt everything, and it wasn't even a blink, right? So, but typically the way we push it out is one package at a time, only because there's not a value of spending the, say, 3 hours that it's going to take to run through the scripts that are going to basically rebuild everything and all that. There's definitely a security benefit to going down that road where you are rebuilding your environment constantly so that anybody tinkering in the environment is basically wiped out. But right now, it's incremental pieces that we're pushing.
Yeah, to be fair, I was going to say, to be fair, there have been times during production releases where we've actually decided, and sometimes not even really publicized, and we're just like, all right, we're just going to rebuild the whole production environment, and we've done it, and it's just consistent. So it's not, we don't run into any problems by doing that. And
right now we've got the deployments kind of broken up into different types of applications, so that when we run that particular type of application deployment, it'll make it consistent with what's in the CMDB. So if it's only this one application that was changed for that version, it will only be that one application that gets deployed. We do have it broken up like that. With this kind of release automation workflow, it'll help provide a mechanism to push those changes in an automated manner without needing to run this particular job to deploy the batch applications, for instance.
yes.
So you guys looked at Ansible Tower and going with Ansible. Did you find that there was any functionality that you kind of wish would have been available when you did your evaluation, and maybe they would have done like use Ansible and something, or did kind of Ansible give you everything you needed in order to be successful?
The CMDB was kind of the piece that we didn't see that was easily storing and controlling the configuration. Like you can use the variable files, but it's kind of limited to an extent, and it's not nearly as dynamic of a means. So,
Is it called dynamic?
We would have run into that issue with anything we selected, though. So that wouldn't have been something that was just Ansible. That wouldn't have just been Ansible unique. So that would have been the case with any of the tools that we would have selected. But in terms of like things that Ansible doesn't have, I mean, given that you can pretty much design your own modules and customize your own modules, I mean, we do have a handful that we've done on our own as well, and you can pretty much expand it however you like. So we haven't had any major problems or any real complaints about Ansible.
Yeah, probably some of the other tools, at least when we initially started, had a much larger set of supported applications. So we ended up going with Ansible just because of the ease of use, the ability to read it, and it was very, very readable, and the time to actually get it to the point where we actually could build something real. There's pros and cons to them all. Like if you've got a really strong development team that's working on this, maybe another tool is better suited. But it's really like every implementation, you kind of have to look at it, and it's every implementation's unique.
Yes.
As far as the interplay between Ansible and CMDB, like does Ansible call the CMDB to get information, or how does that work?
There's a API call to retrieve the inventory. I think we're up to like a megabyte now or something. It's fairly large, but that is fed into Ansible just with a dynamic inventory, like -I think, is like to provide the file. So.
And it was actually surprising, one of the Ansible talks we listened to yesterday, it was very few people were actually using the dynamic inventories, which I don't think we could have really done without, given the complexity that we have for all of our different environments and all the various config changes and everything.
I mean, to Brian's point, it's a meg for a production environment, which is, I think, about 30,000 lines. I mean, it's JSON, right? But nonetheless, still 25,000 lines of JSON. So it's like, I mean, it's without that, it wouldn't really work out.
It's actually surprising that not many people have been using that for the dynamic inventories, but I think more complex implementations will pretty much require that.
Yeah, and I think we're looking into the process within our company, potentially open sourcing some of these components. So
we'd like to, very much so, and definitely as a pursuit that we have now within Accenture, and same thing with Accenture Federal, is actually pushing all the pain and sweat and tears that went into the CMDB data model, as well as the API layers on top of that, so other folks can generally get going. Because we build a model that really has no business relevance, arguably. It pretty much pertains purely, it's a very flexible model that allows you to put it in there and drive it out the door. Because we spend a lot of time on it, and there's a lot more to do.
Yeah, and it was designed from the beginning to be generic, a way that it could be used for any particular different purpose. So.
Any other questions? Cool. Thanks, guys. Enjoy lunch.
Thank you.